Alright, in this video we're going to take a look at some basic transformation formulas, right, or functions. They're going to be described using these simple function rules. So for example, in this one, our input coordinates are xy, and our output coordinates are negative xy. So essentially all we're going to do is just change the sign on the x coordinate. So hold on. I got a sneeze coming on. But maybe not. Okay. You see different types of notation. Sometimes you see this arrow notation. So it's like original coordinates to output coordinates. Sometimes you see like a function notation. So I think the Greek letter tau. This is like, tau of xy. So this function rule has a name. So these tells me what my input values are. I'm inputting an x and a y. And then here's what I'm doing to those values for an output. So these function rules are basically I'm inputting two separate numbers and I'm doing two separate things with them. Okay? I might be adding or subtracting, I might be multiplying or dividing, I might be doing all sorts of things, but it's like two separate function rules, one for the x coordinate, one for the y coordinate. So I perform those operations, and then I just get some new coordinates and I plot them, see where I land it. So we're going to look at a variety of different ones and kind of see what happens to them. Our first one, like I said, is we're just going to change the x coordinate and make it negative. So let's see. So these output values will be, I might use a different color here, negative 1, and y coordinate stays the same. Negative 1, and y coordinate stays the same. Negative 3, and y coordinate stays the same. So let's see. We've got negative 1, 2. We've got negative 1, 3, and we've got negative 3, 2. Right here. Now it would be good to label this like A, B, C, and over here this would be A prime, B prime, C prime, and I'd want to label where they are here, and I want to label where they are over here to make sure I know which points match up in the end. I think it should be fairly obvious in these examples which points match up, so I'm not going to waste my time or your time going over that. So it looks like what we've done here is just reflect across the y-axis. Right? So changing this x coordinate, and if we had started over on this side and flipped this direction, then all of our x coordinates would have gone from negatives to positives. Right? So same thing. So simply changing the x coordinate sign is a reflection across the y-axis. Next door here, now we're going to do a similar rule. This time we're going to leave the x alone. It stays the same, but we're going to change the sign on the y-axis. So what do you think is going to happen? Let's find out. Alright. So 1 stays the same, but 3 becomes negative. 1 stays the same, but 2 becomes negative. 3 stays the same, but 2 becomes negative. So let's see, it's 1, negative 3, 1, negative 2, and 3, negative 2. So it looks like this becomes a reflection across, wait a minute, that's not right. Yeah, goodness sakes, messed this up. Plotted all my points wrong, so I was in a hurry. There. Looks like this becomes a reflection across the x-axis this time. So changing the sign of the coordinate for the y-coordinate reflects across the x-axis. There you go. Next up, let's see, this time we're going to change both signs. Let's see what happens. So let's see. So 1, 1 becomes negative 1, negative 1. 1, 3 becomes negative 1, negative 3. And 3, 2 becomes negative 3, negative 2. So let's see. There's negative 1. This is negative 1, negative 3. And this is negative 3, negative 2. So let's see. 1, 2, 3, down 2. Wait a minute, something's wrong. Oh, because I plotted this point. 1, 3, negative 1, negative, hold on a second. I did something wrong here. There we go. That's not the 0.11, it's 0.12, which makes this -1, -2, which puts that point right here. Right? So what you'll see here is that we end up with a rotation of 180 degrees. But also notice that that rotation is made up of a double flip. So we could flip across the y-axis and then across the x-axis to end up here. So reflect across x equals 0 and y equals 0 separately. That'll achieve the same thing. So it's either a double reflection or it's a rotation. And I want to point that out because actually every single one of our transformations, no matter what they are, can somehow be achieved through some series of reflections. So all of our rotations could be achieved by some type of a reflection. Same would be true of translations as well. But I want to also point out, notice how changing the x-coordinate, that's what flipped it across the y-axis. Changing the y-coordinate is what flips it across the x-axis. And so you can see how that rule is kind of a combination of the two ones that we looked at previously. And that can happen a lot. A lot of our rules can be sort of combinations of other rules, and kind of keep an eye out for that. Next door here, let's see, something a little different. We're going to flip the coordinates. So we're going to input xy, but we're going to output yx. So we're going to flip them. And here, by the way, I wanted to use a different triangle for a reason. So let's see, we got 5, 4. And that's going to become 4, 5. Flip the coordinates. 7, 4 becomes 4, 7. And 7, 5 becomes 5, 7. So let's just plot those 3. 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 up here. So there we go. And you see what we have here is a reflection across this line right here. Okay. Now, by the way, this line is the line y equals x. So this kind of makes sense a little bit. I reflected across the line y equals x by switching all of the x and y coordinates. In a sense, there's a, think about it anyways. I'm not going to go into too much detail about it, but think about that. The equation is y equals x. Y is the same as x. This is the collection of all points where y and x coordinates are the same. So if I were to reflect a point that's on the line, like the point 5, 5 or 2, 2 or 6, 6, then it wouldn't move anywhere because I would just switch the coordinates and it would be the same location. Anyway, so reflecting across this line here is just a matter of switching the two coordinates around. All right, let's look at another one. Here, we are going to, switch the coordinates again, but this time we're going to change the x negative after we flip. Okay? So this could be a little complicated. So let's see. The flipping, so it's going to become 2, 1, but the 1 is going to be negative. And here it's going to flip and it's going to be 3, 1, but the 1 is going to be negative. Here we're flipping, it's going to be 2, 3, but the 3 is negative. So let's say that gives us 2, negative 1, 3, negative 1, and 2, negative 3. Okay. And this is a rotation. We could either say it's negative 90 degrees, or we could say it's 270 degrees. So either the rotation went 90 degrees in this direction, or it went 270 degrees in this direction. However you prefer to look at it, it's the same rotation, with the center being, of course, at the origin. One thing to point out about this is, see how we flip the coordinates? That's a reflection, and changing the sign is also a reflection. So really what this is we took this, and there's a lot of overlapping shapes to show it, but if we were to reflect this across that line and then flip it over the x-axis, we'd achieve the same thing. So it's either a double reflection or a rotation. And you can see that in the rule, like flipping the coordinates is a reflection, changing the sign on one of them is a reflection. So it's kind of two reflections put together, turn out to be a rotation. So here we have, same deal, we're going to flip the coordinates, but this time we're going to make the y. Alright, so let's the old y, new x. So think about if we previously did that, and we changed the sign over here, then flipping them and changing, that was a rotation and clockwise 90 degrees. What do you think this one's going to be? Let's find out. So flipping it becomes 2, 1, but the 2 is negative this time. 3, 1, but with the 3 being negative this time. And 2, 3, but with the 2 being negative this time. So let's see, it's negative 2, 1, negative 3, 1, and negative 2, 3. There we go. And this is a rotation. And this is a 90-degree rotation. And when we say it's a positive rotations are counterclockwise. So again, the same thing, this is a double flip. If we were to take this shape and flip it across, I'm not going to draw it because when you do it, it would land right on top of itself. Well, we could kind of do that. See, this point would end up down here, this point would end up here, and this point would end up down here. So you can see, and see how if I were to flip that shape over the y-axis, I guess the same thing down here, 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 and then here. If I were to flip that shape across that line, and then I flip it across the x-axis, I land down here, flip it across the line y equals x, and then across the y-axis, I land over here. So in either case, the rotation, or it's a double reflection. And finally, well, let's see, if we ended up with 290 degrees, oh, hold on. Okay, well, we're still recording. This is going to be another double reflection. Let's take this. It's just a sync problem. Okay. So it's our double reflection. It's going to be negative 2, negative 1. Hey, just a minute, but I'm almost done here. Negative 3, negative 1. And this one's going to be negative 2, negative 3. So we're flipping the coordinates. So let's see, negative 2, negative 1, negative 3, negative 1, and negative 2, negative 3. Okay. And what this ends up being is a